Hello. In this video, I'm going to look at solutions of linear systems by the graphing method. So, when we talk about graphing method, we mean that we graph both of the two equations. Now, you might have seen like in a video or in one of the other sections that one way that you can do this, of course, is by graphing the equations. So we have that it is possible that, two equations may intersect each other. So in this case, you have that there's a solution that exists. So you have that there's one solution. Now, the other possibility is that you have that when you graph the two equations, that you find that the graphs of the equations they look something like this, where you have that one equation goes like that, but then you have that the other equation goes like this as well. Now, there's a problem here, and that problem is that these two lines are parallel, meaning that there is no solution. Now, another form that you might find when you graph your solutions is that if you graph your sets of two equations and you find that basically that one of the equations of the lines looks like this, but then you graph the other equation of the line and it's still the same one, well, that means that you have that there's infinitely many solutions. Now, if you're going to study such things like finite or systems of equations in courses like linear algebra, then most likely you'll say something about their systems, which in this case you have that this is a consistent system, you have that this is a dependent system, and then you have that this is a, actually that's incorrect. This one is the, yeah, this one is the inconsistent. And then you have that this is the dependent system. Okay, so these are the three possibilities that you do have. Now, of course, like if you've taken like a algebra course at some point, most likely you've also learned that this is a conditional statement, this is a contradictory, and this is an identity statement. It's all the same. Now, if we were to basically go ahead and try to solve by graphing, um, this is going to be a little interesting in terms of like how do you solve by graphing. So let's say that you want to solve by graphing the following equation, systems of equations. So like let's say like you have x plus y equals to 12, and then let's say that you have 3x minus y equals to 0. So the thing about this is that you're going to probably rewrite the equation in what is called mx plus b form. So like you have y equals mx plus b. And however way that you graph, that's really entirely up to you. So I have that this is equation 1 and that this is equation 2. So from equation 1, I can see that basically if I solve for y, I get that y equals negative x plus 12. Now what this is telling me is that I have an x-intercept at 12 comma 0 and a y-intercept at 0 comma 12. Now for equation 2, you have that if you graph these two equations, that's going to be y equals to 3x. Now in this sense, we do have that, for example, um, that, let me see. Okay, so for this, we just need to graph both of these two equations in the x and y plane. So we can do that. So we go ahead and we graph these two in the x and y plane. Now, basically, one thing that we can make note of is that, okay, so we want to get the y-intercept at 12. So let's do it like this. So let's say that this is 12, okay? But then let's say that we also will say that this is going to be 12. Okay, so this is going to be 3, 6, and then 9. Okay, so we have that we just need to draw a line straight through 0, 12, and 12, 0. Okay, so that's kind of close enough. Now, we also need that if we plug in, let's see, well, if we're going to plug in y equals 3x, then in that case, we need that it's going to look something like this. So you have y equals to 3x, and it looks something like that. So here, we have that this is approximately where they cross each other. Okay, now here's the hard part in terms of like, how are we going to figure out like what's the point of intersection? Well, notice that this was 6, and that halfway between here you have that that's going to be 9. So as you can kind of see, the point approximately where they cross through is the ordered pair 3, 9. Now, we can actually verify that that is in fact the solution because you can plug it in and see that 3 times 3 is 9 and that 12 minus 3 is 9. But another way that you can do this is by using the graphing calculator. So you could probably just plug in negative x plus 12, then just type in 3x. Go to graph, but make sure that it's on standard. Okay. We can actually move the window just a little bit. Like maybe go ahead and say that this is going to be, let's just do 24 just to make it wide enough. -1, and then we'll just say 24 also. That way it's wide enough. Okay. Now see like how we have that we can actually go ahead and trace where exactly did that point of intersection occur, which you see that it's close to 3, 9. But to do that, it's a lot better to do second trace and then just go to intersect, hit enter, enter, and then give it a guess. So the intersection is 3, 9. So we have that the point of intersection is 3, 9. So we know that the solution is the ordered pair 3, 9. Now, let's say, for example, that we try this again with a different set of equations. So let's say that we want to solve x minus y equals to 1. So we'll just say 1. And then let's say that you have negative x plus y equals to 4. Now this is equation 1 and this is equation 2. Now if I'm going to go ahead and just draw these in the x and y plane, I just need to get their mx plus b form. So notice that equation 1, that's really y equals to x minus 1. But then if you go ahead and you look at the second equation, you have that that's going to be y equals to x plus 4. Now this is not very hard to graph because in this case we can actually just go ahead and graph this very easily. So we have, okay, so let's go ahead and just do this, where we have something like that. And if you want to use like a ruler, you can, like if you're working this out on a scratch sheet of paper. Okay, so I know that there's a y-intercept at, or x-intercept at 1, 0, and at 0, -1. So in this case, all I need to do is just draw a line right through here. Now, I also have that there's a x-intercept at -4. This might be a little difficult because I didn't extend it, so like we would have to put -4 right there, and that's -3. So the point of intersection, or the y-intercept, is at 1, 2, 3, and again, I didn't really extend it that far, but we can just do this. So all that we need to do is just draw a line that passes through 0, 4. Oops. Okay, so we just need a line that passes through 0, 4. I think that should be good enough. Okay, so if we just draw that line as follows, and it's okay that the sketch is it's a little off in terms of like how it's supposed to appear exactly parallel. I mean, we can fix that if you want. We can just go ahead and say that, okay, well, so we just need to draw another parallel line through through here, through 1, 0. So, and 0, -1. So we'll just do this. Okay, and then we can get rid of this now. So we can see that both of these two lines, they run parallel to each other, meaning that they actually never will intersect or meet. So in this case, this is a really drawn out way of just saying that from here that you have that there's no solution. So here we have that there's no solution. Now, of course, if you graph this in the x and y plane, those equations were x minus 1. So you have x minus 1, and then you have x plus 4. And if you just go to standard, you can see that both of these two do not meet. So in that case, that's why it's no solution. Now, if you were to try a much more difficult problem, so like let's say, for example, that you want to solve let's say that you want to solve 4x minus 5y equals to 6, and that's equation 1. And then let's say that you have 3x plus 2y is equal to 16, and that's equation 2. Now this is actually going to be a bit more difficult in terms of like finding the solutions to this, but it's easier, yeah, if you write in mx plus b form. So if you write in mx plus b form, basically what you're going to get is that when you solve for y, you're going to get that y is equal to 4/5 x, and then you're going to have that it's minus 6/5. So you can kind of see like how this will be very difficult in terms of like drawing this in the x and y plane, apparently. So you have that's 4/5 minus 6/5. But then the other equation will be y equals to negative 3 halves x, and then plus 8. So these are the two equations that you will put into your graphing calculator. So from there, we just need to clear that, and let's see. So you have that it's going to be 4/5. So alpha enter, enter. So that should be 4. That should be a 5. That's going to be x, and that's minus 6/5. I'm getting a little lazy on rewriting or writing it with the fractions, but it's okay. Okay, so negative 3 divided by 2 times x. Actually, let's go ahead and be careful with that. Let's go ahead and just do alpha enter. Okay, so negative 3 over 2, and then that's going to be x, and then that's going to be plus 8. Okay, so we just need to graph this, and we'll just do second trace, and then intersect, enter, enter, enter. So the answer is 4, 2. So when we graph this equation in the x and y plane, we find that that's going to be 4, 2. Now, you're going to use a different method though as it relates to what you mostly use in finite math, which is elimination method, or really echelon method and Gauss-Jordan method, because graphing won't always work, especially for larger systems. But at least now you kind of have an idea of like how do you plug this into the graphing calculator, or how do you use the calculator. You could have also technically, used like Desmos.com. For instance, like if you have those same equations from before, you just kind of just type them in, and then from here you'll see that it gives you the graph, and then you just click and enter, and it gives you 4, 2. Now, in this case, I think I had a different problem where I had like 3x minus y equals to 0 and x plus y equals to 12, and then you just point and click and it gives you 3, 9, which was the exact same thing. So if you type this into Desmos, it pretty much gives you the solution. But more or less, like you're using the graphing calculator, and you're using the feature that it's second trace and then intersect.